This is question 19 from Module 2 Hard of Bluebook Practice Test number 6. In the given system of equations, P is a constant. If the system has no solution, what is the value of P? In a system of equations, if there is no solution, that means both of the left sides of the equations, if they have the variables, must match exactly, and then they both equal a different value on the right-hand side for the constant term. So let's see if we can get the variables all on one side of the equation and see if they can match up pretty closely. A helpful tip when dealing with fractions, you can multiply every term by either the common denominator or a common denominator. In this case, for the second equation, if I multiply everything by 4, then all of the fractions will be removed. And we would be left with 5x plus 7 equals, since this term doesn't have a fraction, you would still do 4 times p. So that would be 4py plus 15. If I rearrange this so that the variables are on one side and the numbers are on the other, that means this equation can be rewritten as 5x minus 4py equals 8. We can do a similar thing for the top equation. You can multiply everything by 56 if you want all fractions to disappear. However, the only fractions that would cause some concern would be the ones associated with the variables. And thankfully, all variable terms have an x. So if we multiply all of the terms by 8, the constant term will still have a fraction, but all the variable terms won't. If I multiply everything here by 8, that'll give me 7y minus 5x equals 32 over 7 minus 7y. If I move all variable terms to one side, that'll give me negative 5x plus 14y equals 32 over 7. So now we have both equations simplified with much fewer fractions. Now, notice that the left sides are almost identical. The only difference is that the top equation has the opposite sign. So if we multiply everything in this equation by -1, that will change all of the signs. And then we would have 5x minus 14y equals negative 32 over 7. Recall that for a system of equations to have no solution, the constant terms must be different, and they are. We have 8 and negative 32 over 7, so those are not the same value. And then on the left side, all of the coefficients should match perfectly. The 5x's match, so now we need to make sure that the coefficients of the y terms match. In other words, negative 4p must be equal to negative 14. Dividing both sides by -4 results in p equaling negative 14 divided by -4, which simplifies to 7/2. So the value of p is 7/2, or you can also write 3.5.